Ever pondered over the intriguing ways in which we measure the health of vegetation from space? Well, today we plunge into the fascinating world of vegetation indices. These indices are pivotal tools used to estimate vegetation cover and health from satellite imagery. First up is the Normalized Difference Vegetation Index, or NDVI. This index uses the fact that healthy vegetation reflects light differently in the near-infrared and red parts of the spectrum. The NDVI equation, which is the difference between near-infrared and red reflectance divided by their sum, helps us distinguish vegetation from other objects and gauge its vitality. Next, we have the Soil Adjusted Vegetation Index, or SAVI. This index attempts to strike a balance between ratio-based indices and perpendicular indices. It is essentially a ratio-based index where the point of convergence is not the origin, helping to mitigate the effect of soil brightness on vegetation indices. Moving on, we meet the Transformed Soil Adjusted Vegetation Index, or TSAVI. This index takes the concept of SAVI a step further by considering arbitrary slope and intercept values for the soil line. However, it introduces an additional adjustment parameter, X, to minimize soil background effect. Output. Our next stop is the Modified Soil Adjusted Vegetation Index, or MSAVI. This index addresses the circular problem of needing to know the vegetation cover before calculating the vegetation index. It does so by using a variable correction factor based on the product of NDVI and WDVI. Output. The Difference Vegetation Index, or DVI, is up next. This is the simplest vegetation index, primarily sensitive to the amount of vegetation, and differentiates between soil and vegetation. However, it does not account for the difference between reflectance and radiance caused by the atmosphere or shadows. Finally, we have the Green Normalized Difference Vegetation Index, or GNDVI. This index uses the green spectral band rather than the red and is more efficient in discriminating nitrogen. The authors found GNDVI to be more sensitive than NDVI in identifying different concentration rates of chlorophyll, which correlates highly with nitrogen. In conclusion, vegetation indices are vital tools in remote sensing that help us monitor and understand the state of vegetation on our planet. From the NDVI to the GNDVI, each index offers a unique perspective, contributing to our knowledge of the world's vegetation health.